of 81 divided by log of 3 is 4. Okay? So that's your base 10. Now they were expecting you to do these without a calculator though, because we hadn't done change of base in the textbook yet. The reason it's important you know both ways is because your exam is predominantly done without a calculator, right? So you won't have that. You can only use you'd only be doing change of base probably in the calculator portion. All right, what's the answer here? Base is 6, exponent is I don't know, and that equals the root of 6. It's a half, right? Because 6, root of 6 is another way of 6 to the half, so this whole answer is 1/2. All right, so hopefully you guys did okay in all of these. Anything you want to talk about on the rest of page 240? Solve for the variable. Now I'm hoping you guys did your homework. I've been sensing a lot of people not doing their homework, but that's the only way to be successful, right, in this class. Are there any questions you want to talk about in number 6? You want to go over? It had you solving for different parts of a log equation, either solving for the argument or solving for the exponent itself. They never made you solve for the base. Oh no, they did. This is a solving for the base. I was solving for base, INJ. Any questions here you want gone over? Speak now. All right. Page 241, any problems here? Describe, so they weren't asking you to graph, they were asking you to describe your graph. Okay. Page 245. I just asked you to do 1 and 2. So here we were actually using those log. We moved on at the end of Thursday. We moved on to learning about the laws of logs. The laws of logs are on your study sheet or your formula sheet that I handed out last week. Hopefully everyone still has your copy. So they're at the top here. So it's got, notice it doesn't give you the change of base. This is I kind of wrote the change of base in up here. If you want, you can write the change of base on your own sheet. It won't be given to you on exam day though, right? So you kind of have to remember it. So here's the laws of logs. If you have an argument that can be broken up, like if it's a number that can be separated into separate factors, I can separate those factors into individual logs and they're separated through addition. If you have a number, either a division statement or a number that could be divided out, I can divide those into separate logs with subtraction. This is the powerful one, right? If I have an exponent on my argument, I can bring that exponent down as a coefficient. And sometimes the exponent is the unknown, right? That's why you log both sides. Like if you're given a number raised to an exponent, if you log it, the exponent becomes the coefficient. Okay? So number 1 and 2, were there any questions here? It's expressed as a single logarithm, so you're condensing, you're making smaller. Expanding means make bigger, right? 1 and 2, no, Joanna? 2e, let's take a look at 2e. So I've got log of the 4th root of x, I think it's the 4th root of x times y. I don't think that root is on top of the y, is it? Okay, all divided by 100. So the first thing I think I would do is I would break these two apart into individual logs, and then I'd also convert the radical to an exponent. Because notice that the laws of logs have no radicals in them, right? They have exponents but no radicals. Okay, so the first thing I'll do is I'll say log of x to the 1/4, and I think I'll break this apart too at the same time, plus log of y minus log of 100. Okay? And now I'm going to simplify, I'm going to make it as big as I can, I guess. So I would bring this down as a coefficient. So it's 1/4 log of x plus log of y I could actually simplify this too, right? Base 10 to what exponent? I could just call that 2. I don't know if they went that far in the answer key. 7.4, number 2E. Did they? Yeah. So they just simplified that because I could actually find the log of 100. The log of 100 is 2.
Where's the 2?
Here. Log of 100 equals 2. Because there's a hidden base here, right? 10 to the power 2 is 100. Okay, any other questions? I didn't assign that yet, so I'm not going to do it in class yet, but I can come look at your stuff, okay? How about this? Convert to the indicated base. So here, convert to the indicated base. So I just said to you, they want you to convert log 4 to base 3. Okay, using your change of base formula, which actually the notes are, if you wanted to, I'll just tell you on page 242, if you look backwards, here's the change of base formula. Or change of base rule. So that's the one that I included up on the top of my formula sheet, right above my logs. I just wrote it in. If you're given log in base b of any argument, n, that can equal log of whatever base you want, log of a to the n, divided by log of a to the b. So the n stays on top, the old base becomes the argument on the bottom, right? That's how you do change of base. Okay, so getting back to here, if I wanted to change to this statement to base 3, well, I'm going to have to, the only problem with change of base, you're going from 1 log to 2 logs, right? So you have a numerator and a denominator. They're both in base 3. The 35 stays on top, and the 4 becomes the argument on the bottom. That's what it would be written as a base 3 number. Okay? Probably the only time you'd be asked to convert to base 3 or base 5 or base 4 is at a question like this. The real use of the change of base formula is to change it to either base 10 or base e, so you can use your calculator, right? Those are the big important bases. This is just knowing if you know the change of base rule. How about this? Log in base y of x, change it to base w. Okay, I'm going to give you a sec to record that. Change to base w. These are the type of questions they love throwing on exams, right? Because even if you have a calculator with you, it's not going to help you, right? It's very theoretical, and they know you're just placing variables in the right spot. Who wants to be brave and give me the answer? Agree? Okay, yeah. And just make sure your base numbers are smaller. Shrink the number. It's a smaller font size, and it's dropped down. And these guys are regular size. Right? How about this? Evaluate to the nearest 100th. That means anytime they tell you you can round or use decimals, that's your clue that you can use a calculator. So I'm going to actually write that out. Use a calculator. So I want you to use a calculator to find to 200th means 2 decimal places, right? To 2 decimal places, I want you to come up with answers for A and B. And then you can tell me how you did it. Okay, who came up with an answer for log in base 12 of 6 to 2 decimal digits? I got 0.72. You're close. Did you say 7.4? I got 7.2. Did you get 7.2? Okay, how did you do it? I don't have base 12 on my calculator. Log 6 divided by log 12, and the base is 10, okay? So this is what I get on my calculator, right? Log 6, log 10, or sorry, log 12, okay? Base 10s, right? That's what we get. Did anyone use base E? Could you have done base E with your calculator? Yeah. How would base E look on my, I can convert to any base, right? So I have 2 bases to choose from with a calculator. I could also have done log in base E, so it would have looked like ln 6 over ln 12, right? Watch what happens there. Ln 6 divided by ln 12. It's going to be the same answer, right? So you can choose log or ln. Yeah, it should. And what about this one? What you get for the next one? So log, I know. Okay, I was going to point this out. Watch my calculator. Look at the screen, D. Whoops. What's my calculator doing? Okay, watch this. What does my calculator do? Not every calculator does that. What does it do? Puts a bracket in. So if I put a 6, I want ln of 6, I have to close the bracket off. Right? And that's exactly what D's calculator does. Look what happened. So you weren't dividing by your log 6 slash log, both your logs stayed on top. So you have to close that off, right? So be careful with your calculator. Sorry, where are your logs again? Here, log 6, then you have to close that bracket off, divided by log 12. So pay attention to that, like not every calculator puts the bracket up. Okay, so the next one should be if you just did log -3 log 5 divided by log 2, agreed? -3 log 5 divided by log 2, you should get 0, -6.9 something, yeah? 6.97, I guess? Did anyone put the -3 on as an exponent? Did you do it that way? You got the same answer, right? Yeah, or you could have done this, right? You could have said, well, I want to make it tighter. So I could say, first of all, this is log of 5 to the -3. Then that becomes log of 5 to the -3 divided by log of 2. That's using your laws of exponents a different way, right? So log of 5, exponent -3, close bracket, divided by log of 2. Whoops, I didn't get this. Something happened here to me. Log of 5, exponent -3, divided by log of 2. I got a completely different answer. What did you get, Neville? Did you get -6.97? What am I doing wrong? That's what I had first time. Log, I'm wondering, this is what I did first time, didn't I, guys? Wait. Delete. My calculator is very, okay. So this is what I had the first time, right? 5 to the -3 divided by log of 2, close bracket. That looks good, doesn't it? Does it look good? Okay, this time I got it. I thought that's what I did first. I must have done something weird first time. Okay. Either way, that's how you can handle, if you're given a non-base 10 or base E log and you want to calculate it, you actually want to find the value of it, you can just use a change of base. It's pretty easy, right? Okay, so now we are, let's try, I think we've done that one before. Okay, I think I'm going to leave these for now, and I think we're going to go to our examples booklet. And what we're going to do is we're actually going to get to the meat of this unit, and we're going to solve exponential and logarithmic equations. We've already solved some exponential equations, right? The ones that we could do the same base, like for example, if I give you this, you could look at it and you could solve using a same base technique, but we know, and here's a perfect example, right? Same base technique. Same base technique, this would be base 2, obviously, this would be base 3, right? But then we know we're going to have to take a look at some of these guys, right? If both sides cannot be written in the same numerical base, we have to take logs of both sides. Now, before we get to these guys, we're actually going to spend a little bit of time solving logarithmic equations. Because log equations are what develop when you get one of those tough exponential equations. So let's take a look at some log stuff first. And go back to your the examples booklet. And I'm going to get you to, you can do this change of base, you can look at this change of base. I think we've already kind of established that you guys know how to do this, right? This would just be what, log of 15 over log of 2, log of 30 over log of 5, log of 100 over log of 3, right? If I just wanted to use base 10. Okay, let's move over to, and let's start with solving logarithmic equations. We're going to do logarithmic equations and then exponential equations. So, some tips for solving logarithmic equations. Isolate the logs to one side of the equation. Okay. Once we work through one or two of these, you might see the purposes of this. Combine several logs into one, right? Using our laws of logs, using laws of logs. Once you've combined all logs together, convert to exponential form, solve for the variable. Okay, so, and also check for extraneous roots. That's going to be important. Now, you solved a couple of baby log equations for homework. When you had those questions with x's in them, like you did solve some of these guys. Sorry to keep flipping back and forth, but when on your homework, where was it? Here, on page 240, when you were solving for a variable, these were equations with logs in it. So these were logarithmic equations. You were solving some equations with x's all over the place. So those were types of log equations. But now we're going to see all the types we're going to solve where the x is in the argument. So these are the types of log equations where the true log equations with x in the argument. And we're going to see how we approach these. So I have log in base 4 of x plus log in base 4 of x plus 6. Because they're the same base, I can combine these into one log. Agreed? Okay. That's really the most important part, is just combining multiple logs into one. So how would I combine these two logs? It's multiplication, right? They are separated by a plus sign. If I have two logs separated by a plus sign, I can push the arguments together through multiplication. So this becomes log in base 4 of x times x plus 6. Agreed? All right, that's the hardest part of this equation. Now I think you have the skills to solve it. So what have I done here? The logs were already isolated to one side of the equation. I combined 2 into 1. Once I've combined into one logarithm, convert to exponential form. Can you convert to exponential form? We did that last Thursday. Base 4 to the power 2 equals can you solve for x now? Does it look unfamiliar still? How would you solve for x? It's already factored. How am I going to figure out what x is? What's my next? Yeah, I'd multiply through to get rid of the brackets, right? I think I'd probably find out what 4 squared is. X squared. The reason I have to multiply through is because I have a quadratic, right? If this was equal to 0, if this was 0, it'd be easy. Then I wouldn't FOIL out. It would already be factored and I'd know what my answers are. But I'm not quite there yet. It ends up being a quadratic equation, right? So how do I solve quadratic equations? Push everything to one side and I try and factor. Once again, it was factored here, but it wouldn't help me out because I had a constant 2 that I had to bring over first. Okay, so 0 equals x plus 8 minus 2. Okay, so I solve and I get x equals negative 8, x equals 2. Now, it says check answers for extraneous roots. This is a big deal here. Because the base in a log equation will always be positive. Now we defined that at the very beginning. We said our bases will always be positive. I think if you look back at your logarithmic work, for exponents and logs, the log or the base can be a fraction. It can be, most of the time it's greater than 1. It can be a number between 0 and 1, agreed, or it can be greater than 1. The base will never be 1, because then we're not studying anything, right? 1 to any power just equals 1. The base can't be 0, and it can't be 1, but it can be any positive number, okay? If the base is a positive number, it doesn't matter what the exponent is, if it's positive or negative, but the argument will always be positive. Okay? Because the base in a log equation will always be positive, the argument must be positive. As well. So when I check my answers, let's check. If x is negative 8, what happens to these arguments? The argument becomes negative 8, not possible. Negative 8 plus 6, not possible. That's not a solid answer. 2 would work, right? That makes a positive argument, so my only answer is 2. Agreed? Because once again, if the base is positive, think about this, whatever base I have, whether it's a teeny tiny number, like 0.5, or like a third, or if it's big, like 8, any number that I put for an exponent, whether it's a 2 or a negative 3, how do we deal with negative exponents? We make them positive, right? Yeah. We just write the 8 as a reciprocal, and then it becomes 3, right? I'll never ever get a negative answer, a negative argument, right? Even if I put like a negative 5 here, this is just going to be 1 over 0.5, which is actually 2, right? Okay, 2 to the power of 5. You'll never get a negative argument. Your argument will always be positive. So when you get a negative, when you check your answer, if this becomes negative, you know that's not a solution. It's a false solution. Okay? All right, so after your first kind of more complex logarithmic equation, if you can just use the laws of logs, and remember, you don't have to memorize them because these will always be with you. So anytime you have an equation with more than one log, you think, okay, this is just logarithmic. How do I handle this? Oh, I group the logs together on one side, which they are already. combine 2 into 1. So these are addition again. Now, once you have one log represented, write it in exponential form. That gets rid of your logs, and then you should be able to solve the equation. It might be linear, it might be quadratic. Does anyone else need to form this sheet? Okay. What's exponential form of example 2? What's the base? 10 power 1 equals x plus 3. You can see there's a pattern developing, right? We get another quadratic. So if I push everything over, I get what? X squared plus 3x minus 10. And I think this one factors again, right, Adam? 5 and 2, thanks, D. Plus 5 minus 2. So I get a negative 5 and a positive 2. Are these both good answers? Which one do I have to scratch out? Negative 5, right? So I get 2 as an answer again, right?
Is that right?
Yeah, that's correct. The next one now, I'm going to kind of make a, I think I should have changed the, bullet points because it says combine several, isolate logarithms to one side of the equation. This is an example where that's not necessarily true. I have 3 logs in this equation, right? 2 on the left, 1 on the right. I'm going to show you, instead of pulling them all to one side, as long as they're the same base, you can end up with a log on each side. Because look what happens. Okay, I have 2 that I can combine into 1. Agreed? So if I have log in base 2 of x times x minus 2, and then I have log in base 2 of 9 minus 2x, if I end up with logs on both sides of the equation, I could for sure bring this one over and have it equal to 0. That's fine. But think about it. If I have log in base 2 of this and log in base 2 of this, that must mean that these two guys have to be equal to each other. Agreed? It's the same base technique. It's just like when we had the same base for exponential equations. So you can just ignore these guys, kind of think of canceling them out. That leaves me with x minus 2 must equal 9 minus 2x. If the bases are equal, the arguments have to be equal, right? Once you convert into exponential form, like get out of log form, it just becomes a really straightforward equation, in my opinion, like something you've seen before in your math career. Okay? So I'll give you a sec to solve that one. Okay, what'd you get for answers? 3. Did you have an extraneous solution? -3, right? So I multiply this through, I bring these guys over. My 2x's end up canceling, right? So I'm left with x squared minus 9. I could move the 9 over and get x equals plus or minus 3, or I could factor it as a difference of squares. So I get my 3 and my -3. -3 won't work. It'll make my argument negative. So the only answer will be 3. Okay? All right. I'm going to challenge you to finish these 3. Then take a break if you need one. And I'm going to, maybe about between 5 and 10 after, I'll go over these 3, and then we'll continue on with exponential equations. Okay, so that's your little job, and go for a break if you need it.